Hi, in this video we're going to learn how to name chemical compounds, and the two classes of compounds we're going to look at is ionic compounds and molecular compounds. So first of all, what's crucial to understand is ionic compounds are made from metals and non-metals, okay? So that's like most of the ionic compounds that you're going to see, okay? So metals, you always have to have a metal plus a non-metal. And molecular compounds are compounds that are made predominantly of non-metals, okay? There are some exceptions out here, but the exceptions are very minor, very few, okay? So before we can even dive into ionic compounds and molecular compounds and how to kind of name them and how to deduce formulas, so not just naming compounds, but we also write how to write formulas, okay? Before we do that, we need to understand by looking at the periodic table, which is something you're always going to have access to. By looking at the periodic table, how can you identify where is the metal, where is the non-metal, okay? And once you identify those, then a lot of it gets very easy. So let's take a deeper dive into the periodic table. So in this periodic table, you can see the elements are segmented into green, gray, and blue. All the greens you can see are the metals, okay? So here's a key out here. All the greens are metals. The gray are metalloids, so those are elements with properties in between metals and non-metals. And then the blue are all the non-metals, okay? So essentially, with the exception of hydrogen out here on the left top, everything out here right up till about here are metals. So you don't have to even worry about, just look at the periodic table. Before you can even get into this section, you'll know that you're looking at a metal, okay? And then out here, you have all the non-metals. So the key thing to remember is the metalloids out here that kind of behave like metals and non-metals collectively. But for the most part, you can consider them to behave like non-metals, especially the ones on top. Then as you go to the bottom out here, then they start behaving a little more like metals, okay? The lanthanides and actinides that are down here, so those are also metals. Okay, so now that we understand that, uh, another thing to understand is that all metals form cations, okay, and all non-metals form anions, okay. So let's go back to the whiteboard and kind of break this down a little further and then dive into formulas and then names. Out here we have just a crude skeleton of the periodic table, and I just want you to understand that when you look at the periodic table, if before you can name an ionic compound, it's important to understand where the metals and the non-metals lie in the periodic table. That's number one. Number two is to understand what are the charges of the metals, okay? So there are two types of metals, okay? One is the type of metal that's going to form a cation with only one type of charge, okay? So those ones are going to be, so anything in this group, so group 1 is going to form a charge of 1 plus. So it's going to form a charge of 1 plus. Anything in group 2 is going to form a charge of 2 plus. And then in group 3, you have 3 plus. So those are the fixed charges, okay? So anything in these are going to form fixed charges. Now, you skip over this group, and then from group 5A onwards, that becomes the non-metal. So we'll talk about that in a little bit. So I'm just going to stop at 3 plus for now. So those are your fixed charges. Now, there are a whole bunch of metals that form ions, cations, with more than one type of charge. Those, pretty much a lot of them reside out here, okay? So we're going to call them variable charges. So variable charges, and these ones are fixed charges, okay? So when I talk about fixed charges, here are some examples. So if I look at sodium, actually sits out here, and the group is 1 plus, so that would be Na plus. Out here, if I look, I can find calcium, which would have 2 plus. Out here, let's say aluminum would have 3 plus. So these are always going to have these charges, okay? That's going to change. But if I look in here, let's say I find iron sitting out here, iron can actually have two possible cations. It could have an iron Fe2 plus, or it could have an Fe3 plus. That's what I mean by variable charges, okay? So right now we'll focus our discussion on the ones that can form only fixed charges, and then we'll talk about the variable charges, okay? So let's go ahead and not worry about this. Let's move on to the non-metals, okay? So these are the metals. The non-metals are from group 5 onwards, so that could form a fixed charge of 3 minus. This one could form, so this would be 2 minus, and this would be 1 minus, and out here these are the noble gases. So don't worry about the noble gases, they don't like to combine. So just so that you can quickly identify the groups, this group is the halogens, okay? So that group, those are the halogens. So all the halogens would be 1 minus. Right beside the halogens, you have the oxygen group, okay? So that's all these guys, which forms 2 minus. And then right beside the oxygen, you have the nitrogen group, okay? There you go. So now typically you have the ones with fixed charges and the variable charges that will combine with these non-metals to form ionic compounds. Metal plus non-metal form ionic compounds. Let's take a deeper dive into that. For this part of the discussion, have your periodic table handy and pause the video as necessary. So let's say we're trying to write a compound that forms from two possible elements. Let's say the first element is magnesium, and the second element is oxygen. No, not oxygen. The second element is nitrogen. Okay, so the symbol for magnesium is Mg, symbol for nitrogen is N. If you look at the periodic table based on the discussion we just had, magnesium is going to form a 2 plus charge and N is going to form a 3 minus charge. If we had to predict the formula for this compound, all we have to do is take this this coefficient of the charge from nitrogen and push it down here to make it a subscript in front of the magnesium, and do the same thing from the magnesium to the nitrogen. This is what I call crisscross applesauce. That gives you a compound Mg3N2. Okay, why did we do this? Well, simply because in order for compounds to form, the charges on the cation and the anion need to neutralize each other, which means we have to have a certain number of nitrogens that, when multiplied with that charge of 3, has to equal the number of magnesiums that is multiplied with the charge. So in this case, when we use the crisscross applesauce method, we find out that we need 3 magnesiums. See, 3 times 2 gives you 6 plus, and 2 nitrogens. See, 2 times 3 gives you 6 minus. They neutralize each other, and so you have a charge neutral compound. Now, what's the name of this compound? It derives from the name of the ions. So the name of this ion is simply the metal name, magnesium, and you write ion after it. The name of this is not that easy. You have to modify the name. So the name of non-metal ions typically end up being, you remove the ogen and you replace it with an IDE, ide. So the name of this would be nitride ion. And then when we put them together, you just drop the ion to name the compound. So that would be magnesium nitride. Okay, let's take a look at another one. So let's say we're trying to combine calcium with oxygen. Calcium forms the ion Ca2 plus, oxygen is O2 minus. Name of this would be calcium ion. The name of this would be oxide ion. Notice carefully, that was oxygen. You remove the Y-gen and replace it with an IDE. Okay. How do you write the formula for this compound? You do the crisscross applesauce method, and it gives you Ca2O2. But you want to stop here for a second, because both of them have the same charge, only thing they're opposite in sign. You really don't need 2 and 2 to neutralize it. You just need 1 and 1 of each. So if you're using the crisscross applesauce method, look at the final result and say, can you simplify this to the simplest possible whole numbers? And the answer is yes, because if you divide both by 2, you get CaO. And that is the formula for calcium and oxygen when calcium and oxygen combine. The next question is, how do you name this formula? You take the name of the metal, take the name of the non-metal ion, and drop the ions. So that would be calcium oxide. Okay. Now let's talk about what if you had an ion. So there are two types of ions typically. Let's kind of talk about this for a second. So there are two types of ions. There are monoatomic ions, and then there are polyatomic ions. Okay. Monoatomic means ions that are made of only one type of atom. One type of atom. We saw quite a few of those ions. So if we divide this into cations and anions, all the examples we saw so far were monoatomic. So you have Na plus, one type of atom. Another one would be Mg2 plus, one type of atom. Out here, Cl minus, one type of atom. O2 minus, one type of atom. For polyatomic, turns out you can have a group of atoms can come together and they can have one charge sitting on it. So you have to treat the entire group, okay, as an ion. So you could have cations that are polyatomic, and you could have anions. You have very few cations you're going to come across that are polyatomic, but you're going to come across a lot of anions. So the cations, let me take a look at two examples, very common examples. NH4 plus, see, that entire thing is a group, and it has one positive charge sitting on the group. That positive charge is not on this hydrogen, it is on the group. So I'm just going to circle the group in red, okay? Another example would be H3O plus. Again, the positive charge is not on the oxygen, it is on the entire group, okay? Out here, in the case of anions, you could have CO3 2 minus, oops, not 2 plus, 2 minus. The 2 minus is sitting on the group. Here's another one, OH minus. The minus is sitting on the whole group of OH. So let's take a look at how would you write a compound that combines some of the polyatomics with monoatomics or polyatomics with polyatomics. Before you do that, we need to understand how do you name these, because these are not found on the periodic table. So you cannot take the element name and then try to derive the name. So it turns out these have special names. There is a table in your book that lists a bunch of polyatomic ions, okay, and has their names beside them. Have that table handy. Some of them are just the common ones that we keep seeing time and time again. I would highly recommend try to memorize those common ones. So what I'll do is I'll list out the common ones right now, and I'll name them, and then have those handy in your head, basically memorize them for use for most of the cases. So since we already wrote these, I'll just name these ones for you. This one's called the ammonium ion. This one's called a hydronium ion. Okay. This one is a carbonate ion. So C-A-R-B-O-N-A-T-E ion. This one's called a hydroxide ion. We have another one out here, cyanide ion. Okay, and then let's list a few more on this side. So you can have an SO4 2 minus, so that's a sulfate ion. It turns out if you remove one oxygen from the same ion, see, I removed one oxygen. That would be a sulfite ion. Another side note about these ions out here, the polyatomic ions that actually have an oxygen in them are called oxyanions. Okay, so these ones, these two, and these two would be oxyanions. So it has an element plus oxygen in them, hence the term oxyanions. Okay. Another one would be NO3 minus. That's another common one. So that would be a nitrate ion. Again, if you remove one oxygen, it would be NO2 minus. So that would be a nitrite. And one more that you'll see is C2H3O2 minus. This looks a little complicated, but it's very common. Acetate ion. Okay. All right. So now that we have this list with us, let's take a look at a few examples of how we put these together in compounds and then name them. So consider I have Na plus coming together with the acetate ion that we just talked about. Okay. So that would be a sodium ion. That would be acetate ion. Very simply, crisscross applesauce, since we only have one charge each, that's really going to give us one of each. So that's going to be written as NaC2H3O2. Drop the ion, and so the name of this compound is sodium acetate. Let's take a look at another example. Let's say I have magnesium 2 plus, and we're trying to combine that with a PO4 3 minus, which is a phosphate ion. This is magnesium ion. Okay, crisscross applesauce is going to give me a compound which is going to be Mg3. Now, careful. When you write the phosphate, you're going to end up with two of them. So to denote that, you want to put the phosphate in parentheses and then put the two outside. Okay. Don't ever fail to put the polyatomic ion in parentheses when you have more than one. Okay. So that's going to be called magnesium phosphate. Okay. Very simple. So now that we understand this, so the rules are kind of the same. Don't have to worry too much about it. Let's take a look at a situation where you have variable valency. Okay, so I'm going to, when I say variable, I'm talking about variable charges. So let's take, for example, I have chromium 2 plus and chromium 3 plus. So the name of this, so that's a variable charge metal, chromium. When I name this, because chromium can form two possible charges, I'm going to denote that by putting a parentheses in after the name of the chromium and put a Roman numeral 2 inside the parentheses and put ion out here. I'm going to do the same thing out here, chromium, and I'm going to put 3 ion. This 3 denotes the 3 positive charge. So if I react this with something like, let's say chlorine, which only has one negative charge, right? So if I have to combine them, this would be the chloride ion, right? In both cases, this one and this one. So the name would be, I do the crisscross applesauce, the 2 actually ends up going there. That's only 1 going there, so that becomes CrCl2. There's only one chromium, okay? The name would be chromium 2 chloride. Chromium 2 chloride. Same thing out here. If I had to combine them, that'll go here, that'll go there. So I get CrCl3, and that would be chromium 3 All right. Let's take an example with a polyatomic. So let's say I have potassium from one positive charge. Oh, sorry. Let's take a look at an example with a polyatomic ion. So let's say I have Fe, the 3+ ion. So that would be iron 3 ion, which is combining with, this is an ion that we don't have on the list, so I'm going to write it out, Cr2O7, 2 minus. So that's a dichromate ion. Again, don't worry about the name because this will be provided to you in some form. Remember out here, this is the group, okay? This is the group. So this comes down here and that goes there to form the compound. So therefore you end up with Fe2 Cr2O7 3. Okay? So therefore this one would be iron 3. So you can get from the name dichromate. So as you can see, if you just follow the system step by step, you write out the ions with their respective charges, you write out the names of the ions, then you do crisscross applesauce, and then you write the name. You can very easily go from an element to the name of the compound it forms. And you can, if you follow the same process backward, you can go from the name back to the element. So for example, in this case, if you're given a compound iron 3 dichromate, from this you should be able to figure out that, see, you just separate this and separate that, and you'll say, okay, well, this came from this ion and this ion. From this, you can back into this ion. From this, you look at a table and back into this ion, and then now you know where it came from. Okay. So, but again, it's easy when you see me doing it. You might have to practice it a little bit to kind of get good at it yourself. Let's switch gears and talk about molecular compounds. Okay. So let's talk about two types of molecules out here. Okay. First, so there are two types. One is called a diatomic molecule, and then the other type is called a polyatomic. So within diatomic molecules, essentially the term di tells you there are two types, two atoms in the molecule. Both could be the same atom. So there's a list, there's actually 7 diatomic molecules that are made up of the same type of atom in the periodic table. They're hydrogen, and then they're nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So those are the 7 from the periodic table. Then there are other diatomic molecules that have 2 different atoms. So examples would be HCl. So see, 2 different atoms. You could have carbon monoxide, 2 different atoms, right? Okay. When you talk about polyatomic molecules are made up of more than 2 atoms. Okay, so greater than 2. Okay, so that would be, let's say, ozone. You could have NH3. So see, 1 and 3, 4, right? How about carbon dioxide? 1 and 2 is 3. Okay. What about methane? CH4. 1 and 4 is 5. Okay. So those were the examples. So now notice one thing very carefully. In all these examples we showed you, they're all nonmetals. All of these are nonmetals. So then the question arises, how do you name compounds that are made up of only nonmetals? Those compounds that are made up of only nonmetals are molecular compounds. Only nonmetals. Let's take a look at how to name them. Okay. So in order to name them, all we have to do is understand how many of each are there that are combined in the molecule. Okay. So let's say I have P4S3. both are nonmetals. Phosphorus and sulfur, both nonmetals. There are 4 phosphoruses coming together and there's 3 sulfurs. In order to tell us how many of each are there, we need to, first of all, understand what term to use for those numbers. For that, we need Greek prefixes. Okay, so Greek prefixes, and I'll just show you what we do from 1 to 10. Okay, so if you have 1, it's going to be, you're going to use the term mono. 2, you're going to use di. 3, tri. 4, tetra. 5, penta. 6, hexa. 7, hepta. 8, octa. 9, nona, and 10, deca. Okay, we can go beyond that, but we don't really need to go beyond that at this level. So in order to name this compound, the first element is going to be named by the element name. So that's phosphorus. Okay, now how many phosphoruses do we have? 4. So that's going to be tetraphosphorus. Tetraphosphorus. And then how many sulfurs do we have? 3. So that's going to be tri. But because that's the second element in the list, it'll be named as an anion, sulfide. It's not really an anion, but it's named like that. So tri sulfide. Okay, let's do another one. Let's say we have an N2O4. There's 2 nitrogens, so that'd be di-nitrogen. And there's 4 oxygens, so that'll be tetra, but then it's going to be named as an anion, so tetra oxide. Now here's something interesting. When you have 2 vowels beside each other and you're joining 2 words with them, you drop one of them. Typically, we tend to drop the first one and keep the last one. So this would be tetroxide. Here's one more example, and this one is a little bit of an exception. So let's say we have CO. Okay, we're trying to name this. Whenever you have one of the first element, if it's only one, you don't use mono. But if you have one of the second element, then you use mono. So in this case, it would be carbon monoxide. Okay. Another example would be NO2. We have only one nitrogen, but it's the first one, so we don't use mono. But for the oxygen, it would be a dioxide. So that would be nitrogen dioxide. Okay. So key thing to remember. So this is basically how you name molecular compounds. Remember, when you're naming molecular compounds, they only have nonmetals in them. You're not specifying the charge. Okay. So you don't care about how many. When you name ionic compounds, because they have metals and nonmetals, you have to take into account the charge. Okay. And you don't have to worry about writing how many of them are there. The key thing to remember is if you have variable charges in the metals, so if a metal can form a +2 and a +3, you have to indicate that with Roman numerals in the name. Let's talk about naming acids. Okay, let's briefly talk about how do you name acids. So there are 2 types of acids that we will encounter. One type is called a binary acid. A binary acid simply means it's composed of 2 types of molecules. Example would be HF, HCl, and so on. Okay, let's keep it there. The other type of acid you'll encounter is called a ternary oxyacid. A ternary oxyacid is made up of hydrogen plus an oxyanion. And we already exposed you to oxyanions. Examples would be H2SO4, HNO3. The SO4 is an oxyanion. Combine it with 2 hydrogens, you form a ternary oxyacid. The NO3 is an oxyanion. Combine it with 1 hydrogen, you form a ternary oxyacid. Now, how do you recognize an acid? Typically, the first element would be a hydrogen. Okay. Now, How do you name a binary acid? A binary acid you just start with, call it hydro. So it'll always start with a hydro, and then this one would be called fluo. You would use the element name. So the element name for F is fluorine. The INE would be replaced with IC, ic acid. Okay, so hydrofluoric acid. Now, how would you know it's an acid? If it was written this way, then it's not an acid. You have to have an AQ, an aqueous, then it's an acid. Okay, if it's simply written as HF, then that would be written as hydrogen fluoride. And sometimes you put a monofluoride. Okay, if you put an HCl, writing it as an acid, look for the AQ. That would be hydrochloric acid. Why chloric? Because chlorine, INE, you drop the INE and replace it with IC. Let's take a look at how to name ternary oxyacids. So you'd name it after the name of the oxyanion. So the oxyanion would be the original oxyanion out here would be SO42 minus, so that would be sulfate, right? Sulfate. So you would change the ending and call it sulfuric acid. So the 8 gets removed with an uric acid. Okay. Out here, the oxyanion is a nitrate. Then acid would be a nitric acid. So now, whenever you're naming them, ternary oxyacids don't start with a hydro. The binary ones start with a hydro. Okay. And then the ternary oxyacids always take into account the name of the anion, and you modify the name to introduce an ic. So you would think that this would be a sulfic, but turns out it's the rules, of course, when they were made so that it would be a sulfuric acid. Sulfuric acid. Okay. Now, it turns out sometimes if you were to take the sulfite ion, so when it's 8, it becomes ic. So let me erase this. So let's say you had H2SO3. So that would come from a sulfite ion. Let me write that properly. When it's ite, then the acid would be sulfurous acid, OUS. So ite becomes us, and and 8 becomes ic. Okay, so if it's HNO2 minus, that came from a nitrous ion. So therefore, nitrite ion. NO2 minus is nitrite ion. So therefore, the name of this acid would be nitrous acid. All right. So it's important to understand where the acid came from, what kind of a polyatomic ion. Takes you back to that polyatomic ion chart that I mentioned earlier. Let's wrap up this discussion by talking about how to name hydrates. Okay. How do you name hydrates? A hydrate is a compound that actually, it's an ionic compound that has some molecules of water combined with it in its formula. So you might have heard of Epsom salt. Epsom salt is essentially magnesium sulfate combined with some molecules of water. So that would be MgSO4. And the molecules of water, you'd know it because there's a little dot out here and a 7H2O. So it turns out each molecule, each unit of MgSO4 combines with 7 molecules of water. Okay, so that would be Epsom salt. So the question is, how would you name this? Well, you'll name that part first. So that would be magnesium sulfate. And then you name this using Greek prefixes. Okay, this water is called a hydrate. And then since there's 7, the prefix you'd use is hepta. Hepta stands for 7, hydrate. Okay. Let's take a look at another one. SrNO3 twice, 4H2O. How would you name that? Strontium. Nitrate. 4 tetra hydrate. Hope that made sense.